Good morning, students. Welcome to online class, Department of Collegiate and Technical Education, Automobile Engineering Department, 5th semester. We are studying the subject Design of Machine Elements, that is DME. So we are in unit number 4, that is Design of Simple Machine Parts. So today we have to study session number 8, that is Design of Cotter Joint. Before starting this session, let me introduce myself. I am Mr. Vinayak S. Nayak, Selection Grade Lecturer, TSIT Polytechnic, Hubli. So in the previous session, that is session number 7, we have studied regarding the couplings, design of muff coupling and design of flange coupling that we have designed. So in that, the function of the couplings, types of the couplings, and designing of sleeve or muff coupling and designing of flange coupling we have studied by referring the design data handbook. So today in session number 8, the contents are: number 1, introduction to Cotter joint. So what is the Cotter joint, what is the function of the Cotter joint, and how it connects the two bars or rods, in that we have to study. In the second one, what are the advantages of Cotter joint, because we are having so many joints, but what are the advantages of Cotter joint over the others, that we will study in the advantages. And applications where we are using the Cotter joint, so that we will study in the applications of the Cotter joint. Third one is types of Cotter joint. So we are having around 3 types of Cotter joints. What are they? That we will study in the types of Cotter joints. Fourth one, socket and spigot Cotter joint. This socket and spigot Cotter joint is one of the type of Cotter joint, and here we will study about the socket and spigot Cotter joint. Fifth one, design of socket and spigot Cotter joint. So how we have to design the socket and spigot Cotter joint, here we will study in the fifth one. And in the sixth one, we have some question answers and homework is there. So what are the questions and what is the homework, we will study and we have to do before the next session. Seventh one is multiple choice questions. So shortly it is known as MCQs. So already you are familiar. One question is having 4 answers. Out of 4, 1 will be the correct answer that we have to choose. And 8th one is the references. So what are the reference books which I have referred for preparing this session, so that we will study in the 8th one, that is references. Dear students, let us study one by one. Number 1, introduction to Cotter joint. So this is our Cotter joint, which is having the main parts. So the Cotter is joining the 2 rods or bars with the help of here the socket and the spigot. So Cotter joint is a type of temporary fastening. So already we have studied regarding the temporary fasteners and permanent fasteners. So here the Cotter joint is one of the type of temporary fastening, because without damaging the components easily we can dismantle the parts. So that's why it is known as temporary fastening. It is a mechanical joint. which is used to join two axial rods or bars. So this quarter joint is used only to join two axial rods or bars. This joint does not allow any angular movements of rods which it connects. This joint is applicable for tensile loads as well as compressive loads. See, on the quarter joint, the tensile loads as well as compressive loads are applied. So this joint is applicable for tensile loads as well as compressive loads, and it is a detachable joint. That's why it is known as temporary fastener. So then we have to study regarding the advantages of quarter joint. So number one, it can take tensile and compressive loads. So the quarter joint takes both the loads, that is tensile as well as compressive loads. Second one, it cannot permit angular movement. Third one, it is not subjected to bearing failure. In this, taper or clearance is provided. So this is the advantages of the quarter joint. Then we have to study regarding the applications of quarter joint. Number one, it is joining piston rod with crankshaft head. Second one, it is connecting a piston rod to the crosshead of a reciprocating steam engine. Third one, it connects stop end of connecting rod. Fourth one, it connects a piston rod and its extension as a tail or pump rod. Fifth one, quarter foundation bolt joining two rods with a pipe. So these are the applications of quarter joint. Dear students, next we have to study regarding the types of quarter joints. What are the types of quarter joints? The following are the three commonly used quarter joints to connect two rods by a quarter. A. Socket and spigot quarter joint. Here the pronunciation S-P-I-G-O-T is spigot. So number one or A is socket and spigot quarter joint. B. Sleeve and quarter joint. And C is gib and quarter joint. So number one, socket and spigot quarter joint. So here first we have to study regarding the construction and working of socket and spigot quarter joint. So this socket and spigot quarter joint is having mainly three parts. One is a spigot, second one is a socket, and third one is cotter. So here we have mainly three parts here. This is the socket and this is the spigot, which is connecting by a cotter. So that's why this type is known as socket and spigot quarter joint. So first one is the spigot. So this is the figure of the spigot is here. So here this is the slot for the cotter. This is the spigot and here the rod is there and this is the collar of the spigot. So it is male part of the cotter joint. So the spigot is the male part of the cotter joint. It is the part which gets inserted into the socket. It has a rectangular slot for the cotter to pass through it, and also it has collar which rests against the socket end. Next is the socket. So this is our socket is here. This is the socket and this is the socket rod. This is the slot for cotter, and again this is the collar of the socket. So this socket is female part of the cotter joint. It has a hole in which spigot fits. It also has a rectangular slot for the cotter to pass through it. Next, the third main part is the cotter. So this is the cotter which is in taper in section. So the width at the top is more than the width at the bottom. So it is a taper in section which is inserted or which joins the socket and the spigot. So it is a part after which the joint is named. So that's why it is named as socket and spigot cotter joint, because we are using cotter. So by using the cotter, the name comes that socket and spigot joint. Socket and spigot cotter joint. It is wedge-shaped piece of rectangular cross section and its width is tapered either on one side or both sides for an easy adjustment. This part enters into rectangular slot of spigot and socket. It first enters into upper slot of the socket, then passes through the spigot and then passes through lower part of socket. Once again, I will explain how it is connected to the two rods. The three parts, spigot, socket and cotter, together forms the cotter joint. Firstly, spigot enters into the circular hole of socket and then cotter fits tightly into the rectangular slots of spigot and socket, which coincides with each other. Thus, cotter fixes the spigot and socket with each other. A taper is used to lock the joint. This taper is easy to remove and makes the assembly to dismantle easily. Taper also ensures the tightness of the joints and prevents loosening of the parts. The load is usually acting axially, but it changes its direction, and hence the cotter joint must be designed to carry both the tensile and compressive loads. The compressive load is taken up by the collar on the spigot. So next is fifth one is the design of socket and spigot cotter joint. So here this is our socket and spigot cotter joint. So how to design this? So I'll explain one by one. So this socket and spigot cotter joint is connects the two bars or rods along with the cotter. So here the rod A is here and the rod B is here. So at one end the rod A is there and at another end the rod B is here. So which are having equal diameter or same diameter. So this is the diameter of the bar or rod. So here first we have to design the diameter of the rod by taking the load applied on the rods. Second one, so this is the inside diameter of the socket. This is the inside diameter of the socket, or also it is equal to outside diameter of the spigot. So inside diameter of the socket is equal to outside diameter of the spigot. Next step is we have to design for the outside diameter of the socket. So here the outside diameter of the socket is here. So this we have to design. Then when we come to here, we have the socket collar is here and spigot collar is here. So we have to design the diameter of the spigot collar. We have to design the outside diameter of the spigot collar, and also we have to design for the outside diameter of the socket collar. After designing this, we have to design for the thickness of the spigot collar. This is the thickness of the spigot collar, and we have to design for the thickness of the socket collar. After designing a socket and a spigot, we have to design for the cotter. So already I explained the cotter is in taper in section. Usually it is in 1 in 24. That means at the top side it is a 24 ratio, whereas at the bottom it is 1 in ratio. So that's why 1 in ratio. So first we have to design for the mean width. We have to take at the center, because at the center mean width is available. So we have to design the mean width of the cotter. Then we have to design for the thickness of the cotter. After that we have to design for the length of the cotter. So after designing socket, spigot and cotter, we have to keep some clearance here. So the clearance is around 2 to 3 mm for removing of the cotter easily. So this is the design of socket and spigot cotter joint. Dear students, once again I will explain this. The different dimensions of the cotter joint and the designing of the different dimensions are on the basis of load carried by the rods. First we have to design the diameter of the rods. Second one, diameter of spigot or inside the diameter of socket. Third one, diameter of spigot collar. Next we have to design thickness of spigot collar. After that we have to design for the distance from the end of the slot to the end of the rod. Then we have to design for the outside diameter of socket, diameter of socket collar. After that thickness of socket collar, and we have to design for the cotters that mean width of cotter, length of the cotter, taper in cotter. After that we have to keep some clearance of the cotter along with thickness of the cotter. So these are the different dimensions of socket and spigot cotter joint, and we have to design for all these dimensions. The permissible resistance on socket, spigot and cotter are permissible tensile stress for the rod material, permissible shear stress, and permissible crushing stress. For all these stresses, the units are either megapascal or Newton per mm square. So, 6th content, that is question answers and homework. Dear students, I will give some questions as a homework. Number 1, identify the different parts and their dimensions of the cotter joint. So when you are familiar with the different parts of this socket and spigot cotter joint, then it is easy to design with their dimensions. And second one is practice the multiple choice questions. So in the multiple choice questions, we have some questions and each question is having 4 answers, and all the questions are based on this session only. So you have to practice the multiple choice questions. Let us study multiple choice questions one by one. Number 1. A quarter joint is used to transmit. The options are A. Axial tensile load only, B. Axial compressive load only, C. Combined axial and twisting loads, and D is axial tensile or compressive loads. So here in the designing of quarter joint, we have studied that a quarter joint is used to transmit axial tensile or compressive loads. So that's why here it is in the option number D. So D is the correct answer. That is, a quarter joint is used to transmit axial tensile or compressive loads. Second MCQ. The taper on quarter varies from A. 1 in 15 to 1 in 10, B. 1 in 24 to 1 in 20, C. 1 in 34 to 1 in 24, and D is 1 in 48 to 1 in 24. So here already we have studied that quarter is in taper in section and the ratio is varies from 1 in 48 to 1 in 24. So here it is in the option number D. So D is the correct answer. So the taper on quarter varies from 1 in 48 to 1 in 24. Third option. In a steam engine, the piston rod is usually connected to the crosshead by means of A. The options are A. Knuckle joint, B. Universal joint, C is flange coupling, and D is quarter joint. One of the application of quarter joint is in a steam engine, the piston rod is usually connected to the crosshead by means of a quarter joint. So here the option is a D, that is quarter joint. Next, fourth one. The material of the quarter joint. A. Stainless steel, B. Mild steel or wrought iron, C is carbon steel, and D is alloy steel. So usually the quarter joint is made up with a mild steel or wrought iron because it is having the properties which is required for manufacturing the quarter joint. So the material of the quarter joint is mild steel or wrought iron, that is B is the answer. Fifth one. Quarter joint is a method of this joint. The options: A is a temporary joint, B is a permanent joint, C is semi-temporary joint, and D is semi-permanent joint. So already we have studied that we have two joints. One is temporary joint and another is permanent joint. So our fasteners, quarter joint, knuckle joint, all they are the example for temporary joint, whereas welding, riveting are the example of permanent joint. So the quarter joint is a method of temporary joint. So here the option is A, that is a temporary joint. Sixth one. Quarter joint is applicable for. The options are A. Tensile load, B. Compressive load, C. Both A and B, and D is none of these. So here the quarter joint is applicable for tensile load as well as for the compressive load. So here the options are there in A and B. So the option both A and B is the correct answer. So quarter joint is applicable for both A and B. A means tensile load and B is the compressive load. So the correct answer is C, both A and B. Seventh one. Cotter is. Options are A, square in section, B, compressive load, C, tapered in section, D, all of these. Here what you have studied is that the cotter is only in tapered in section because at the top we have more width rather than bottom width. So it is not in square section and it is not in compressive load. So the cotter is taper in section. So the option is here C, that is cotter is tapered in section. Eighth one, it is not a part of cotter joint. See students, already we have studied what are the main parts of the cotter joint. Here in the option A is a socket, B is a spigot, C is cotter and D is knuckle. So socket, spigot and cotter are the parts of the cotter joint. So option A, B and C are wrong answers. But the knuckle is not a part of the cotter joint. So here the option is D, that is knuckle. So the knuckle is not a part of the cotter joint. So dear students, now I conclude this session. I hope you understood this session, and these are some reference books which I have referred for preparing this session. I am thankful to LMS team and our LMS team chairman, LMS coordinator, moderator and subject expert for giving this opportunity to me to present this session. For any queries or doubts, please mail me. And my mail ID is tsitpnaik11@gmail.com. Thank you very much.